The most powerful companies on Earth are racing to build artificial intelligence. But the real bottleneck may not be intelligence. It may not even be chips. It may be something much older, much heavier, and much harder to scale: electricity. In public, the A race looks like a battle of models. OpenAI, Google, Meta, Amazon, Microsoft, Anthropic, AI. Each company wants the smartest system, the fastest product, the biggest platform. The biggest platform behind every chatbot response, every image generator, and every AI agent. There is a physical machine burning real power. And this is where the story changes. Because AI is not only a software revolution, it is becoming one of the largest infrastructure projects of the modern age. Some estimates now describe the next wave of AI spending in the hundreds of billions and even trillions of dollars over the coming years. The clearest symbol is Stargate. OpenAI, Oracle, and SoftBank announced a plan to invest up to $500 billion in AI infrastructure in the United States over 4 years. The first phase alone was described as $100 billion. But the more important number may not be the money. It may be the power. A modern AI data center can demand electricity like a small city, not for 1 hour, not for one launch week, all day, all night, every day of the year. And when thousands of expensive chips are training a model, even a short delay can cost millions. But here's the part most people miss. You can order GPUs faster than you can rebuild a power grid. You can raise money faster than you can permit a transmission line. You can announce a data center faster than a utility can connect it. For years, the internet felt light. We tapped a screen and software appeared. Search engines, social media, streaming, cloud storage. It all looked weightless, but the cloud was never really a cloud. It was buildings, land, water, electricity, diesel backup, cooling systems, and contracts. E makes that hidden system much larger. Training large models can require huge clusters of accelerators. Running those models for millions of users can require even more capacity. The old internet served pages and videos. The new internet thinks, predicts, summarizes, writes, draws, and reasons in real time. According to the International Energy Agency, global data center electricity consumption was around 415 terawatt-hours in 2023. By 2030, it could reach about 94.5 terawatt-hours. That would be slightly more than Japan's current annual electricity consumption. In the United States, the numbers are just as serious. The Department of Energy reported that data centers used about 4.4% of total U.S. electricity in 2023. By 2026, 7 and 24%. That is not a small app update. That is a national energy question. And that range matters. At the low end, data centers become one of the most important new loads on the grid. At the high end, they start to reshape how states plan electricity for everyone else. Homes, factories, hospitals, schools, and campuses all begin asking the same grid for more power at the same time. Goldman Sachs Research has projected that data center power demand could rise by around 160 to 65% by 2030. In the U.S., data centers could use about 8% of the country's power by the end of the decade. For utilities, this is a new kind of customer. It arrives quickly, it asks for enormous capacity, and it cannot accept downtime. This is why the A boom feels different from the smartphone boom or the social media boom. Those revolutions change behavior first. A is changing behavior and industrial demand at the same time. It needs chips from Taiwan, servers from global supply chains, fiber networks across continents, and then in the final step, it needs a local utility to say yes. This creates a strange new race. Big tech is not only competing for engineers and chips, it is competing for land near substations. It is competing for natural gas turbines, solar farms, batteries, nuclear deals, water rights, and local political approval. Very few people outside the industry understand how hard this is. A data center developer may secure land and financing, but still wait for a transformer. A utility may want to serve the customer, but need new transmission. A community may want jobs, but worry about water, noise, and electricity prices. The bottleneck is not one thing. It is the whole system. But the turning point is this: electricity is local. You cannot download it from another continent. If a region does not have enough generation, transmission, or grid capacity, the data center cannot simply wish itself into existence. The smartest A model in the world still needs a plug. That is why A companies are making deals that sound more like energy companies than software companies. They are looking at long-term power contracts. They are talking about nuclear energy. They are placing data centers where electricity is available, not only where talent is located. The problem is not that the world has no energy. The problem is timing. A new AI model can appear in months. A new power plant can take years. A major transmission project can take even longer. This time mismatch may decide which companies win the next phase of AI, and that gap is where the quiet battle begins. Not on a stage, not inside a product demo, but in planning offices, grid queues, and construction schedules. And there is another pressure point: cost. If electricity becomes harder to secure, it does not only become more expensive for companies, it becomes more expensive for users. The free chatbot era may not stay free forever if every answer depends on scarce compute and scarce power. This also changes the business story of Nvidia. Nvidia sells the chips that made this new era possible, but a GPU is only part of the machine. Without enough power, cooling, and networking, even the best chip becomes a stranded asset. The question is no longer only who can buy the chips, it is who can actually turn them on. For OpenAI, the challenge is even more direct. Better models may require more compute. More compute may require bigger data centers. Bigger data centers require more energy. So the company that wants to build artificial general intelligence is also being pulled into one of the oldest industrial problems on Earth: how to produce and deliver power. This may explain why the numbers are becoming so large. The money is not only buying servers, it is buying buildings, land, cooling, networking, backup systems, power agreements, and years of construction. In the old software world, scale meant more users. In the AI infrastructure world, scale means more concrete, more copper, more steel, and more megawatts. For Google, Amazon, Microsoft, and Meta, the stakes are different but just as high. They already run the cloud. They already own global infrastructure. But AI threatens to absorb every advantage they have. A company can have money, talent, and customers and still hit a wall if the grid cannot keep up. This is why the next few years may look very different from the last decade. The winning AI company may not be the one with the loudest demo. It may be the one with the loudest demo. It may be the one with the loudest demo. The best supply chain, the best financing, the fastest permits, the strongest partnerships with utilities. But there is a risk. If AI infrastructure grows faster than the grid, local communities may push back. Electricity prices could rise. Water use could become political. Emissions targets could become harder to meet. The technology that promises a smarter future could collide with the physical limits of the present. There is also a strategic risk. If only a few companies can afford the energy, land, chips, and financing, then they may become more centralized. Smaller startups could be forced to rent intelligence from the giants. Countries with weak grids could fall behind. The AI race could become a power race between corporations and nations. Still, this does not mean the AI boom is fake. It means the boom is becoming real in a new way. Real concrete, real steel, real megawatts, real political choices. Every major technology revolution eventually leaves the screen and enters the ground. So when people ask whether AI is a bubble, they may be asking the wrong question. The better question is, can the physical world keep up with the digital dream? Because if electricity becomes the limit, the future of AI will not be decided only in research labs. It will be decided in substations, power plants, and grid control rooms. The AI race began as a race for intelligence. Then it became a race for chips. Now it is becoming a race for power. And the company that solves that problem first may not just build the best AI. It may build the infrastructure of the next century.